Hi everybody, Sean O'Kane here with Chip Estimate TV. We're here at DAC 2014 in San Francisco, California, and my guest today is Peter McGuinness, Director of Multimedia Technology Marketing with Imagination Technologies. Thank you for joining me today.
Thanks for asking me, Sean.
And I appreciate the keynote earlier in the day. Wonderful.
Thank you.
It was a packed house.
It was.
So, Peter, I want to really get into this. It's really clear that the wearable and IoT revolution has pretty much begun. And a lot of people are talking about it. And Imagination Technologies is pretty much at the heart of it all right now. So wrapped around this technology and this revolution is Imagination's Power VR graphics technologies, which looks to be the de facto standard for mobile and embedded graphics. That said, why is GPU compute important and what apps are driving it?
Okay, well, GPU compute is an opportunity as well as an enabling technology for mobile. It's an opportunity in the sense that there's already a GPU on the SoC. Every mobile SoC has a pretty powerful GPU on there, and it's not necessarily used all the time for its primary purpose, which is to generate fantastic high-resolution game quality graphics. And so there's a lot of compute power which is available as a result,
right.
And so the opportunity is to take advantage of that. Now the enabling technology part of it is that the GPU is structured so as to perform bulk calculations on massive data sets very, very energy efficient, in a very energy efficient way.
Right.
So it's the enabling part of the technology is really that it enables us to do more computation within the restricted power envelope that we have inside a mobile device. Yeah.
Good. Now, continuing with that, are there common GPU compute requirements between mobile, consumer, high performance compute? And secondly, will there be any overlap between the two?
So there are common compute requirements, certainly between mobile and consumer, and I think they will turn out to be pretty much the same, and it is the same apps which are driving them, which are vision apps. Between those two segments and high performance computing, not so much. The techniques may be similar, some of the calculations may be similar, but with HPC you need things like 64-bit floating point. You need things like very fine-grained control of the computational distribution across a heterogeneous system. These things are not necessarily required in mobile, and in fact, in order to work within the mobile power envelope that we need to stay within, a lot of the requirements for HPC need to be left to one side, just to focus on what's really important for mobile.
Let's talk a little bit about mobile. Smartphones are smart, but they're getting smarter. Mm-hmm. And the next big thing in mobile phones is to have a very rich sensor environment. But the big promise has been the always-on and context-aware, mm-hmm. like Fitbit and the Nike Fuel Band. Mm-hmm. The challenge is to make this a reality, and that the power computation has to be really low power.
Right.
So the question is, that's a long lead-in, how is the architecture of mobile SoC changing to accommodate the emergence of always-on and aware apps? Mm-hmm. Secondly, what is needed to drive power consumption down to levels which make sense for wearables?
I think the answer to both of those two things is contained in the same concept. Power efficiency is driven by taking as much of the low-level computation that you need to perform and driving it into commoditized hardware implementations. And so I want to mention a standard which is emerging right now. It's OpenVX, which is a Chronos standard. And that's aimed at standardizing the functions which underlie, the very basic functions which underlie the bottom level of visual computing. And once they're standardized, they can be placed behind an API, and as soon as that happens, of course, we can commoditize them and put them into hardware. So that's one way of driving down power. Now, the always-on aspect is just as interesting, because the sensors consume a lot of power, and the primary sensor for always-on and aware is the CMOS imaging sensor, which consumes a lot of power.
Right.
So what we need is, and what we're developing, and we're seeing it to happen, is a kind of a staged awareness. There's fully awake, there's not quite paying attention, there's having a snooze, then there's deep sleep. And all of these things have to be layered in order to get the right power profile. And that applies pretty much to wearables too, except that wearables don't have they don't generally have the same graphical requirement. So perhaps we'll see a different compute element used as the heterogeneous compute element in wearables from a mobile, and we'll also see different display requirements.
Okay, so let's talk about the Power VR Rogue. We briefly talked about that before, and how games will use GPU compute with the Rogue.
Okay, so I do talk to game developers about this, and they always say, you want me to use the GPU for something that's not graphics? And the answer is, well, maybe. And there are some things which can be used using GPU compute, and in this case we're really talking about OpenGLA's 3.1 shader compute. That's the likeliest API that's going to be used in that context. So you can use that in order to implement physics engines, things like collision detection and other things like that. But there are certain imaging features that you want to put into games. Games can also use the camera, and so you can run filters through like that. Global illumination is another big thing, and there are techniques such as dynamic light map baking, where you can bake a light map in the game, and that takes quite a lot of computational power, and it's appropriate for GPU compute. So those sorts of things will use the GPU in a non-graphical sense, but applied to a graphics problem.
Wonderful. I appreciate you spending a little bit of time with us today here at DAC 2014. Peter McGuinness, right here, Director of Multimedia Technology Marketing with Imagination Technologies. For Peter McGuinness, my name is Sean O'Kane, and we'll see you next time on Chip Estimate TV.